And so for today, yeah, I see recording just started. Hi, everyone. So for today, we have 𝗔𝗯cie 𝗛𝗁, who is a community member who's been helping us with the DevCamp 7 and with a lot of other stuff with Holochain development, is walking us through the changes in the new version of Holochain called RSM. And he would be covering changes from the architecture, design, and development standpoints. So, 𝗔𝗯cie, I think you can take away from here.
Yeah, thanks. So hi everyone. Can you hear me well? Yeah. So I think we know each other, everyone here. The people that I don't know from the last DevCamp, I know from previous DevCamp or other meetings. So yeah, we are pretty good set. Although I think I was expecting. I don't know. I feel like the participants of the meeting already have a lot covered about RSM, a lot of knowledge and so on. So maybe I don't know. We'll go through the original plan, but anyway, maybe we could do a little more back and forth to see what's interesting for me to dive into, or questions or conversations that are worth exploring. But first, like I know Fali and Martin, you came into the last playtime, so I don't think it would make much sense to basically go over that a little bit. Alex and now Jonathan, hi, welcome. Have you reviewed some of the RSM material? Have you watched some of the playtime videos that have been published these 2 past weeks?
So I've looked over some of the articles written by Art and like the DevPulse, and I've like watched like the recent AMA, and so I'm a little bit familiar, but yeah, I would like to just watch whatever you have to present, or and just like learn about as much as I can about the framework.
Yeah, okay. What about you, Jonathan?
I saw one video sent around, not two. So I watched the first one, I guess.
Okay, perfect. So what do you think? Would it make sense for me to dive into the code a little bit, just so Alex can get a sense of, okay, what has changed in terms of the syntax and what are things looking right now? And then maybe we could go over the migration guide for those that about that, show a little bit the differences between RSM and the previous version, or any suggestions. Any of you have any suggestion? Yeah.
Sorry, it's Martin. Just to ask what the migration guide is. Maybe I'm out of touch, but is it that the comparison you put up, and maybe it's is it on GitHub or forum post? I can't remember, but you put a list of sort of calls and API that's sort of partially implemented or coming up, or and implemented. Is that what you mean by migration guide, or is there something a bit more sort of formal out there?
Yeah, no, that's not what I mean. That's the feature list. The migration guide is what I just sent into the chat. It's drafty, but I think it works well as a starting point. And it, without being very long, it gives a sense of the amount of things that have changed and the direction of those.
Yeah, I think it makes sense maybe to start with sharing your screen doing the code, but I think open for everybody, please interject with all of the questions you have. And it's a small enough group that there can be discussions, and I think different people know different parts of RSM, and yeah.
Okay, perfect. Yeah, thanks. So I'll be sharing my screen now. Okay, so can you see my screen? Okay, so this is the migration guide. We are going to come to it afterwards. Okay, so for those of you that it's the first time seeing RSM code, this is what it looks like. The structure, I'm going to go over this pretty quickly because a lot of people here already are familiar with this. So the structure is similar to what we had before. We have the 𝗔𝗯cie folder, test folder, and then inside the 𝗔𝗯cie we have our 𝗔𝗯cie code. Okay, but syntax is basically completely different, and there are some important things that the new RSM version is doing differently, a little differently than the previous version. As Caroline said, please feel free to interrupt and tell me, hey, we already know this, you are boring, and so on. So very briefly, yeah, so you're looking at an example DNA, which is calendar events. Okay, so let's create a calendar event. Let's see all the calendar events you have in your calendar and whatnot. So here is the way in which you define HDK entries, so holochain entries. So it's just struct, and this struct has to implement this this macro, right? So this substitutes the entry definition we had with all the validation and so on. So one of the things that you already have are starting to see is that in the new holochain, everything is simpler, cleaner, and it's more split up. So it's not like in the entry definition, we are doing link definitions and validation and configuring everything in one place, but it's much more, okay, here is the entry definition, and in another place of the 𝗔𝗯cie, you can define validation code, and in another place, you can create links. So in a sense, and this is a general comment about RSM in global, it's much less opinionated on the way you want to do things. It gives you more flexibility, both on the syntax level and also on the design level, but that affects, like, you have more responsibility as an app developer when developing for RSM. But as you can see here, the general flow of different functions have not changed that much. So we are defining structs, creating them. This is the new anchor stuff. I'm going to talk about that next, I think, because we didn't see this in previous playtimes. And now you create links, whatever links you want, return the hash. For those that it's your first time seeing this, it's important also. Headers are much more important now that they were in previous versions. So basically what they realized was that headers are a much more intrinsic part of what the data structures are like. So in the previous version, it was just headers were a way of guaranteeing security and timestamping and preventing people from rolling back. But in this version, a header is analogous to the act of speaking, and the entry is analogous to the content that has been spoken. So if you think about it, whatever anyone does in the real world, it's important both what they do and who and at what moment they do it, right? So these both sides are very present throughout the code. Okay, how am I doing until now? Any questions, any clarifications, any your boring stuff?
Well, for me, this is valuable, refreshing, and you could probably go over this another 2 or 3 times, and it still be valuable. Yeah.
For me, the analogies break down sometimes. So a cleaner technical discussion of header and content. I followed it, I think, in the first video when you spent extensive time about talking about it. But I'd want to see like the data structure of header and the data structure and how they're linked and like that.
Sure, let's go. I think that's something that people want to see also from other playtimes and so on. So perfect, let's go see it.
And if that's redundant, you covered it, and I need to watch a second video, I'm happy to just watch an old link so we don't waste people's time.
No, I think it's the first time we are going to see this, and I think it's very, very important. So let's go do it. Okay, so let's see, header. Okay, yeah. So this is what headers look like now. And it's weird in a way because this is an enum. And if you know Rust, I think everyone here does, it means that not all headers have the same properties. And this is important because previously things like creating a link or updating the entry or things like that would have their own entry, their own special entry type, which would specify, okay, this is a link from this entry to this entry, or we are updating this entry or whatever. Now, all that information is stored in the headers always. And one of the important things here is that you basically are saving one entry to be stored on the DHT. Because previously, when you wanted to update an entry, you had to commit, okay, this header, let's commit that. This entry, let's commit that. And then you had to notify the previous entry, hey, you have been updated. And I'm talking now these things that you are notifying the DHT, because actually what you're doing is the update command has to change some parts of the DHT, right? So these things are called DHT operations. Basically here, you're saving a DHT operation with everything now included in the header. Anytime you want me to go deeper into some concept, just tell me and I will go a little deeper. I'm just trying to sense what the interest, where is the interest. We can continue reviewing the headers though. So here are all the different kinds of headers that you can have. So this, for example, let's go see the DNA header. So the DNA header is extremely simple. It's the simplest header. You have the author, you have timestamp, you have the hash. No previous header because DNA is always first chain entry. So if you remember in the previous version, you would have a previous header hash, something like that with an option. And sometimes that made sense and sometimes it didn't. So in this way, you are preventing any confusion. The DNA never has last header hash. All the other ones do have header hash, the previous header hash. These are other ones, agent validation package, which is, this is really cool now. So in RSM, when you install DNA, you can pass some membrane proof, which is, hey, I have this invitation code, I have this ticket, I have this signature from an authority or whatever that allows me to enter the DNA. And when you are calling the validate agent, which is the agent ID function that controls the membrane, that function can check the membrane proof and say, yeah, you're valid or no, you're not valid, right?
So could you share more about the operations of that? Like, how does that proof get there? Like, how is it assigned?
Right. Yeah, this is really simple actually. So when you call install DNA, you will be able to pass some parameter, membrane proof, and that's it.
So there could be like a master list of which agent IDs are permitted?
Sure, you can do whatever you want, but I don't think you need a membrane proof for that, because the agent ID is already here.
Would that be a possible like potential cause of hotspotting on the DHT?
How would in what sense? What would
if say like if many nodes are trying to perform a validation
right.
using information from or through a single like node, or like it's like a sort of a bottleneck that can
okay. So actually there is no bottleneck. So whenever you want to validate an agent, it's not that you go to the agent and ask for the membrane proof. The agent enters the DNA with the membrane proof already, and that gets disseminated to the DHT. So that's the process. And then all these nodes in the DHT already receive the membrane proof and already have all they need in their own nodes, so they don't have to go to the agent, to the joining agent.
Hi, just a question. So, can we use this membrane proof during the? Not sure if it's still the same fallback name in the validate agent fallback. We can access this.
Yeah. Without if that were not the case, it would be useless. The membrane proof would not be useful, because you could actually do the same with an entry in your application. So that's the sole purpose of the membrane proof. Yes.
And Guillaume, you mentioned that you can pass the membrane proof through like install DNA. Where is it, or what exactly is the install?
Right. So whenever, and this has some details still to be addressed, but whenever you want, you will be, whenever you download an application and you install it, someone is calling the Holochain conductor API, so this one. Right, so someone is calling the, this is the substitute of HC web client, and someone is calling here, let me see, the admin interface, and it's calling install application, right? In the past, that was the job of Holoscape. In the future, I think that will be the job of Holochain in the background, something like that. So anyway, someone will call the conductor admin to install the application. So in that call, you will be able to pass the membrane proof. Because this membrane proof, what it's important about it is that it can be different for every agent. Otherwise, you can just code it or add it in the properties. So imagine if the membrane proof is, and this is a real case that we are designing with Hedayat, if the membrane proof is a ticket of, hey, have you paid to be able to join this course? And actually this is LIB, so you all know about it. So in the future, maybe in LIB, you will be able to pay for a course and then receive a ticket. And the ticket is your public key plus the signature of the ticket of the teacher. So now you install the application with the ticket as the membrane proof, and then the validate agent checks if the ticket has your public key and it has been signed by the teacher. And if you think about it, that's different for every agent. It doesn't make sense that a teacher does the same ticket for everyone, because then anyone could potentially join the DHT.
and sorry, can I just ask a question about that? And again, I don't know much about this, so I apologize. But is that then validated by the other nodes before they'll gossip, or how is that? What's the mechanism that is enforced?
Right. So when the agent joins the network, actually installs the application, it generates these initial headers we were seeing. So it generates the DNA header, the agent validation package header. First, it generates the, no, it doesn't. That's all. And it generates this init zones complete. And once those are generated, it tries to gossip them. What's the thing? The thing is that in Holochain, before starting any connection to any node, that node has had to be validated. Okay. If you're not, if you haven't been validated with a validate agent, no one will ever talk to you, like not even to gossip or anything like that. So the first thing that a node joining the network tries to do is spread these first headers for them to be validated. And then they can start, hey, I'm in this part of the DHT, blah, 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 blah.
That makes sense. Perfect.
Cool.
Alex, your hand's raised, at least in Zoom.
Well, if Alex comes back, I think we can ask him again. Okay, so we can finish seeing what the headers look like. So this, for example, we have create link. So sorry, these three are kind of mandatory at the first part of the short chain. You will always see the same three being committed at first. This is part of the Genesis workflow. And now we are arriving to headers that get committed when you do HTK commands. So when you do create link, it actually does the create link header. And here, yeah, you can see that it's pretty simple in the sense that it has basically same information. This is the basic information that was in the headers already from the previous version as well. But since this is a create link header, now we have the create link information. So from which entry to which entry, zone ID and tag. And previously there was this link type in the previous version. Right now there isn't. So links don't need to be defined. Like in the previous version, they are much more dynamic. So you can link two entries, whatever they are. And if your validation doesn't reject that, they will be valid and everything will be okay. It's much less rigid and much more flexible in that regard. And another important change is that in this link tag, you can now pass complex structures. So if I want to, I don't know, pass some ticket, if I want, not only a string, I can pass a ticket here. And actually it won't take too much of a performance hit. So, okay, things that we are seeing that are important now. If you see the delete link, it has the link at address. So previously, with updating, deleting, and so on, what you would say is, okay, let me delete the link that goes from this entry to this entry and has this type. But there was some ambiguity, because what happens if there are two links pointing from the same entry to the base entry to the same target entry, and I delete one of them? Like, will all the links be deleted? Will I get 1 or will I get 0? I don't know. So in here, this is where headers are becoming more important as well. So when you say delete link, update entry, or delete entry, what you are saying is delete this header. So delete link requires the link at address, so the address of the header that created the link. Okay, and that link will be invalidated then. And links actually are non-ambiguous right now because they don't carry with themselves an entry. So if you have deleted the link with this header and there are 2 headers, you will get 1, the one that hasn't been deleted. And with update and delete, more or less the same. So update has the original header address, and delete has the header address of the delete. So deletes now work as reference counts. So if you deleted all the headers that were that had created the entry is dead. But if there is any one header which has not been deleted, which created the entry is alive. You know, you understand how it should work. So in a sense, yeah, it works like a reference count. And then we have things like create, which is basically what we always had. The entry hash is the important one here. So these are headers. I think that this more or less covers what you wanted, Jonathan. If you want me to go deeper in any of the topics I touched, just tell me.
That's great. Thank you.
Yeah.
What about the reborn? If all the header are deleted and another one is coming and adding the same entry, the reborn is possible? Yeah,
reborn is possible. So in the previous version, there was this tombstone set, which meant that if you create the entry again, create the entry again, how many times, it didn't matter. And then delete the entry will be deleted because one delete overrides all the creates. Here, that's the case only for the headers. Okay, so if there is, actually I won't even touch that because that's impossible. You can create 2 headers because it's the same header. So, sorry about that. So in the new version, you have, let's say, let's do something sketchboard. Okay, I think this will be, let's see if we can make it work. So let's say we have header 1, right? And header 1, is creating entry 1, okay? And now there is a new header that says delete header 1, okay? So delete header 1 is referencing the header. So right now in this state, the entry will be dead because there is no one header that hasn't been deleted holding the entry. But if I create I create the entry again, the header will be different because I cannot generate 2 headers that are the same. So now the entry will be alive. And if I create a new header, actually the state won't change. The entry will be alive as well. But like the fact that multiple headers are here can be used for validation or some things like that. But as far as entry CRUD status goes, the entry will be alive still.
What's the flip side of this? My head is immediately thinking of this could introduce a complication that wasn't there earlier.
In what sense?
I don't know. I just feel like this is going to create some new, like a new set of problems.
But it's a resurrection, right? It was deleted and it was properly deleted, and now it's suddenly alive again.
Yeah.
That seems like a new feature.
Would this create problems during get?
Right.
Like if there's multiple.
Yeah, you have a point sheet in that in validation rules, for example. So you want to get an entry in a validation rule and you want the validation rule to be deterministic. So you don't like this now on, now off behavior. So first of all, you can control that with validation rules. So you can say, no, actually deleting the entry is not valid. And second, the validation rules will actually retry if they don't get the entry. So because in Holochain, actually, it's very difficult to tell apart an entry not existing or an entry having been deleted only from the get. Like the get wouldn't get you that. The get details would get you that. So this is another instance of Holochain not assuming what you want to do and saying, hey, if you want, I can send you all these headers, and your validation rule can become not whether this entry is alive or not, but whether this entry was created by this agent at that point in time. And that will be deterministic.
Got it. So we would have to specify which header we want.
Or just use the retry function of the validation rules. Like get is going to retry if it doesn't get the entry. So you can just say, okay, validation won't pass until the entry is alive as well, alive again. But this will impact validation time. So you have to understand this pretty carefully to be able to say, I'm going to use this mechanism that Holochain provides.
Cool, thanks.
Sure.
So in that case, the logic of a get entry doesn't make sense. We just need to have a get element, because getting the entry without the reality or event of a header doesn't make sense at all. Entry is just the hash of data, actually.
That's a really good point. And the get now gets elements, not entries. So just so you know, an element is the header and the entry, basically. And elements, like most of the HDK calls, if they are not doing it right now, they will deal and return elements instead of entries or instead of headers, so that you have a full picture. You have who did it and at what time and what's the content of what they did.
So what about the order of the operation? And so regarding the CRDT, so 1 plus 2, 2 plus 3, what 2 plus 3 equal to 3 plus 2. So right now, how we take care of the order of the operation? It is the timestamp, how it is working?
No, I think that in the previous version, we had that problem because updates and deletes referenced entries, but in here we don't have that problem actually, because it's basically deterministic, because you are saying I'm deleting this header. So you can't have weird behavior.
Yeah, sure. So
it's not like this create and this delete reference the same entry, so which one will win? It's like this delete deletes this header, so we know deterministically, okay, we are deleting this header.
So, and the callback, it doesn't make sense here. It means if I'm going to update a element that is already updated before, So it means it's gonna happen, or I'm supposed to receive the callback to make a decision.
Right. So let's do updates then. So let's say that, yeah, this header creates this entry, and now this header comes and it updates this header.
What do you mean when you are telling update the header? It means the content didn't change. I'm going to, what does it mean when you are telling update header?
Well, right now, when you want to update a thing, you update the header, not the entry. So you're saying that thing that I said yesterday, actually, I wanted to say this.
Okay.
You're not saying the content that's written on the blackboard is now crossed and this is the new thing. You're saying, I said hello yesterday when I wanted to say bye-bye, but that doesn't mean that hello is replaced. That means that what you wanted to say is replaced.
You're updating element, not just
exactly.
the entry.
Exactly. So practical implications of this. You can update entries multiple times.
And the fork is not gonna have any place here, yeah?
Wait, let me.
Can you put an entry, not circle, for example, rectangle as entry, different shape for entry?
Okay, let's see.
Yeah.
Square.
Square.
Why we don't have rectangle? Yeah. Thanks. So this is a perfectly valid scenario, and this is like I remember when Connor learned about this. He said, "App developers beware." Because here you can see basically that this entry will have a trios of updates. Not only that, this update could have multiple updates as well, which is perfectly fine as far as Holochain goes. Holochain is not assuming your update mechanism. Holochain is not following the update chain to get the latest version and update that one, because that had problems with eventual consistency. It's telling you, hey, what do you want to do with updates? Like, you have to basically think what's your best update mechanism and use it. In the future, this is what we have right now. In the future, you will have a callback, which they are naming redirect, which means if you want us to handle all this complexity for you, like be able to say, get me the latest version of this entry, okay, we can do that if you tell us which one of these paths we should follow. So there will be a callback, and the callback will be like, okay, an array of headers, and which of the headers should we follow for following the update chain and get the latest version of an entry. And this will be executed on this path, on this path, and then on this path with the multiple updates on this path, like all along the tree. So you could say things like, follow the header with the higher timestamp, and then it will actually follow the update tree, the latest addition that has been made. But be careful, because latest header in the first entry does not mean latest header in the whole tree. So you have to think carefully about this. But this is what we have to do now as Holochain developers, more so than before.
So first of all, when the callback is going to be called, when the second fork, it means when the subconscious recognize, oh, wait a second, I see another header on this entry, another element. a people or a person just committing a new fork immediately receive a callback to make a decision?
Yeah, yeah.
So, and that one is telling, okay, it is selecting which one is valid. It's selecting for the whole network, yeah?
Yeah.
For the whole application. Okay, it is the first one. Second one.
Wait.
Okay.
I think it will be at zone level, not at DNA level. If you are defining the entry in this DNA, like different entries will have different update strategies, I assume.
Mm.
So it doesn't make a lot of sense to do it at the DNA level, because then that would conflict things.
Zoom would receive a callback, you mean?
Yeah.
So Zoom would receive a callback, but after resolving the result, the result is going to be DNA level. It means it's going to be distributed in DHT.
Yeah.
So that's cool. So two topics you mentioned about the timestamp. Again, we are going to do timestamp. Timestamp, it is the subconsciousness of the Holochain core is adding, yes?
Yeah, I was referring to the timestamp of the header, but that can be attacked. Like, you have to figure out what prevention you do. If you're going to write that rule like that, you have to figure out how you prevent partition attacks. Or maybe not, because you don't care about security too much in this application. I don't know.
And what about concurrency? The big application, a lot of good morning Twitter at the same time, 8. So what's gonna happen? It means 10,000 people would receive 10,000 different callback and update and select or something like that.
No, so the callback is not executed at write time, it's executed at read time. So actually, Holochain in the DHT it's not storing what's the redirect. When you make the call, it actually calls the callback, and the callback should be like not even milliseconds, right? So it should be really, really, really fast.
Callback, it's gonna be on read. It means when I'm reading, I need to make a decision which one I'm supposed to do.
Exactly, yeah.
How will this callback be so fast? So it would have to retrieve all the data from DHT about headers?
No. The callback would receive a list of headers and expect you to return one, something like that.
Oh, so you are responsible for retrieving all the headers for the callback. So you are doing all this work before, no?
So you, in the callback, Holochain is already passing you the headers.
Mm-hmm.
So you don't have to handle all that.
Mm-hmm. But this gathering of headers, in order to be passed in callback, it has to take some resources. Or
no, not really, because they are all on local.
Oh,
so
they would be all local even if you weren't the one who created all the headers?
Okay, so any one node that receives a request of what does this, what's the latest version of this entry, will have all the headers that update that entry in their DHT shard.
Mm-hmm.
So actually they all have in the local database, they have all the information they need to call your callback, because they are an authority for that entry.
Oh, I see.
And that's why DHT operations are so important.
So just to clarify, I understood you correctly. A node that is responsible for the first of all, headers that are related to an entry would be stored close to each other in the DHT, and therefore there would be a high chance that a single node would store all these headers. So when it has to decide what's the header to retrieve according to the callback, it would have all this data available locally.
Yeah, exactly.
Okay, cool.
So actually you have to think it like this. When things that are spreading throughout the DHT, sometimes the entry is spread, but always the header is always spread to the DHT, accompanying whatever command.
Mm-hmm.
So if you are storing the entry in this part of the DHT, the header is beside the entry, and it's stored like, here is the entry, and here are the multiple headers for this entry.
What about the hotspots then? If I have an entry that had millions of headers, would all of them be still placed on a single node, or they would be just redistributed into the nodes that are very close by?
So if a node is responsible for an entry, that node is storing all the headers for that entry. And actually, that's the same in previous Holochain versions. So yeah, that's a potential hotspot there.
Okay.
Again, who code is responsible to select the valid reality or fork, or the user supposed to select from UI?
I'm not getting.
So the callback is coming that telling, hey, the place you are calling, you are getting, I have this fork, I have another fork. So who is supposed to select that? I would like this reality. I would like.
Yeah. So the agent, in an agent-centric way, more agent-centric than before, when I'm going to read, I can decide what reality to follow.
User supposed to see something in UI and select.
No, not necessarily. Your read code of your Holochain node can do that for you. You can say things like, get me all that has happened in all history with this entry. Let's get details.
Okay.
You retrieve the entry with all the headers, and now you say, okay, I want to apply my particular mini algorithm to follow my own reality. You process everything that has happened, and you say, okay, now I want this one. And you go and select, and that's running on the read function of your Holochain application. So that's agent-centric, because if a node wants to fork their own code to see reality in a different way, they can. You cannot do validation rules on how they perceive things, because it's not right, it's read.
Could you explain that better with an example? Like, what could we potentially do with this?
Yeah. So imagine, okay, let's see. Do we have, yeah, perfect. We have a person here. So imagine, let's see, okay, all this is true. Okay, let's see. All this is stored on a node, right? This is in the DHT shard of one node, all this information, right? But other nodes are going to come and are going to, hey, get me the latest version of the entry, or get me the information about this entry. So what you can do here in the node, oops, no, I want a circle. I want, yeah, that's okay. That's a Holochain node, okay? So in this node, I can say, in the get, I don't know, get latest version of entry one, okay, whatever. So this function can be running different things. So for example, let's say that I say get details entry one, okay? So it will come here, request the details for this entry, and fetch them basically. Oops, sorry about that. And the details will include everything that's happened with the entry, so all this stuff. And now they can say, okay, decide which header I like best, whatever, and then follow the header and fetch and repeat. Okay, so this would be one possibility. One user, like, for example, I like headers with latest timestamp, or I like the headers of the people I trust most. Like, you could do it like that. And then
geography or whatever.
Yeah, whatever. So, yeah. And then, oops. No, I want to copy this. Another user comes and is executing the same code, or maybe a fork version of the code. Like here, it doesn't matter. No. And they are executing the same Holochain DNA, but maybe they have configured that I like headers from people I trust.
Does it make sense the user can in a UI select, yeah, there are, which one would you like?
Like, it does make sense, but the process will be extremely cumbersome, depending on the use case, right? So if I have to be asking the user, the end user, decide on the latest version of this entry, decide on the latest version of this entry, just to retrieve it, like, I see that as a edge behavior you would want to implement. But in some cases, it could be done, yeah.
Yes, so there is a chance to set this parameter from the UI. Yeah, okay. Or the parameter of the it's the callback, right? You are passing to the read function.
No, actually, it's not even a callback. It's the actual code here, which is the get my calendar events. You can do stuff here. Okay, so get first calendar entry with headers, and then decide on personal filter I have on local, and then retrieve whatever's left. And then, like, this is, we are not talking about even callbacks here. You can already do this with right now.
Again, what is the default behavior if a developer forget or don't want to implement this callback? Is there what is the behavior of a default subconscious of Holochain? Goes to timestamp again and go to see regard. What is the default?
No, the default is that get do not follow update chains. So get will get you the entry original, the original entry that created the hash.
So you get what you're asking for. You have a header. Yeah, okay.
Exactly. I have to plug the charger. Just 1 second. Okay.
So in that case, the latest version is a matter to, if we want to have it means the application is supposed to implement a strategy to list. It means it is not like a previous one. We get for any version, we would receive a latest version. If we need to want to, does it right now, in that case, the latest version or a final version doesn't make sense at all, generally. It means maybe we have a different reality. Which reality the latest version?
Like this is one of the things that Holochain is doing more. It's not assuming the update strategy of your application, because updating somehow requires to have a consensus of what content has been updated to this other content. So it doesn't it doesn't assume anything. It just gives you the tools so that you can decide. And that's more responsibility on us.
It would seem that any application that anticipates long-running forks has to build in its consensus mechanism, has to build in another data structure to navigate this tree for you and persist it so that you're not recalculating huge trees over time, right? It would just be a design decision that you'd have to take.
That's a good question. I have heard that to optimize all of this, maybe in the future, if you provide a callback mechanism, the updates along the way will be propagated backwards so that this entry knows that 100 updates later, it has been updated to this one, and this is what the developer wants because we have their callback. So I don't have to follow the whole chain. I can just, from this entry, okay, latest version is that one over there. Like, don't even know if, whatever, you know?
Like a fast forward. You'd still have to calculate from there, but at least you can skip the 100 in between.
Yeah, exactly. But like I said, this contradicts a little bit to the fact that I said that it's on read time, because this is still on works. Like right now, there is no callback mechanism, there is no back propagation. It just multiple headers work, and whenever you do a get, you get that that entry, not an updated one.
So just a question. So right now, we get all the headers and we don't have the redirect, but we can still implement a way for us to return whatever we want from the Zoom level to the UI. Is that correct?
Yeah, exactly. Okay. Here you can do whatever you want.
Right. But do you get the headers that have been attached to the headers? So if I get entry 1, I don't know about entry 2 or entry 3 at all. How do I even discover that they exist?
Right, and that's the main difference between get and get details. So, okay, let me try to. It's cargo docs open, right? Cargo doc. Be fast, please. Oh no, it's not going to be fast. Okay. Okay, let me explain and then I'll show you some documentation. Let's see if this is fast. So get only returns you the entry with the latest header that committed the entry. I think that's right. Get details get you all the information about that entry, even delete headers and update headers. And the update headers carry with them what new entry there is. So actually, with get details, yes, you get the full picture. You don't get, though, what entries have updated entry 2. Because it's not that information is not local to that node. It's local to the node that's an authority for entry 2.
What do you mean when you are telling latest version? Which one is right now latest version?
Like right now I said get returns the latest header, not latest version.
Latest header.
Yeah.
So right now, without details, which header? Timestamp, yeah? The default timestamp telling which, okay.
I think that's the case. That may change though.
But across all forks.
Oh, what was that, sorry?
Sorry, across all forks, the latest header across all forks.
No. Latest header of that entry. It doesn't even try to go see new entries, new updates. That's the behavior right now.
So it follows the update chain, but only for the headers that are related to a particular entry.
No, it doesn't follow the update chain, because if it did, it would return you entry 2 or entry 3. And it's returning entry 1 with the latest header of entry 1.
Oh, so this is when multiple agents commit the same entry and they create multiple headers for the same entry.
Exactly. So I'm going to delete this because, oh, okay. Wait, let me finish this point. Okay, so imagine here there are multiple headers. This is perfectly normal. Get returns this entry and the latest of these ones.
Yeah, that's what I was talking about.
Okay. And now we have the documentation and we can go see. You can see get and get details and get. Well, the documentation is very wordy. You don't have examples, but this gets you the element, and then get details gets you everything. And you have detailed explanations of what the behavior are right now here.
Can you go to get? When we are calling get, we need to send the entry address or a header address?
Both are possible, actually.
Okay.
Yeah.
So I think when we are designing the peer share, we go to the detail in practice, what version of the file we are supposed to save. Okay, I would prefer to go in practice and talk about such sort of thing. Okay.
Wait, sorry, Guillaume, just a question. So if get accepts either entry hash or header hash, does that mean for entry hash, the latest header is returned, but for header, that header is returned, like whatever hash you...
Yeah, exactly.
Okay.
Actually, when it seems when we are sending header hash, generally we are asking for element. It means I exactly know what I'm doing, what I need. There is no need for any conflict. The topic that when we are asking for entry, I think, yeah? Am I right?
Yeah, so here you can see the documentation of that. A header hash returns the element for that header, the header and entry, or header and none, because remember, a lot of the headers don't carry an entry now. And an entry hash returns the oldest live element, header and entry.
That's great. I think we passed 1 hour.
Oh, yeah, we did. Okay.
Time flies.
Oops, wait. It seems I cannot stop.
I can stop the recording.